I want to show you how to use BlueSky statistics to do a process capability analysis. First, you download the spreadsheet that has the data for capability analysis and put it in a folder, then click Open in BlueSky. First click the three lines at the far left, upper left corner, then click Open. And BlueSky will open the folder or a folder, and you can navigate to the folder with your file. Then just click on the file you want to analyze and click the Open button, and BlueSky will open that file. Now, we've already done that. Our file has 25 subgroups of 5, and it's organized as shown here. And what you do is you click Six Sigma Process Capability and pick Process Capability QCC package. We've done that. Here are our inputs. Go up to the top, and we have two options. We chose option 2, and option 2 lets you analyze data in the format of our data. So I copied the samples over to option 2. Then I put in the lower specs, and the problem tells you the specs are 100 plus or minus 10. So the lower spec is 90, the upper spec is 110, and the target, the middle of the spec range, is 100. We left everything the same down to the standard deviation method, and I picked this standard deviation, which is unweighted average range, called U-wave-R. And then I checked the box to plot the underlying X-bar and X-bar 1 charts used to compute the process capability. So when I click the execute icon, BlueSky comes up with this set of data. And you can go to the data set and start highlighting right about here, which is number of observations equals 125. And just highlight the rest of this down to there. And this is the process performance analysis. So they start with the PP letters, and the text, the Six Sigma handbook and our course describes what those mean. So then I copy those, and I went over into a Word document where I'm preparing my report, created a little table with a couple of rows, actually three rows in 2 columns, and I pasted those into this worksheet or into this document. So here's the process performance indexes. And a little further down in the BlueSky output, you get the process capability indexes, and they're called CP. They start with the letters CP. So BlueSky gives you the value of the index and the 95% confidence interval on the index. So you have some feel for how variable that index is. Next, we navigate a little further down, and BlueSky produces the capability chart. So the first chart is based on the process performance index. And I hope you recall that the process performance indexes are based on the standard deviation of all the data combined. Later, as we go down this list, we're going to look at the process capability indexes, and the standard deviation of that is based on only the subgroup within subgroup variation. So as I say, you go a little further down and you can highlight the process capability analysis. And by the way, I've changed the terminology. BlueSky calls both of these process capability analysis. I don't. I call this one a process performance analysis because it's for an out-of-control process. They still use this analysis, but it's not valid because it's out of control, so you don't know what the future process is going to look like. I term it process performance index to indicate that's what we're looking at. The process capability analysis is comparable. In our case, you'll see they're very similar results because the process is in statistical control. So you copy these over. You see the process performance index, it will always be larger than the capability index. This is 0.523. The process capability index is 0.502, so it's somewhat smaller capability index. So you go down, you get another process capability analysis chart. You can open this, by the way, make it larger so you can see it better. And you can then read all the numbers and so on. So this might be a better way of looking at the chart because it's bigger and easier to read. So here's our performance indices. Here's our capability indices. Here's the graphical analysis of both of those. And what they show is a process that is not capable of meeting requirements. So the spec lines are drawn in here as red dashed lines. And you can see, obviously, that there are observations beyond the spec lines. The normal curve is a good fit, as we'll see in a minute. And so the expected values are predictable. This chart, the next chart, is they call the X bar 1 chart. That's a chart of the individual readings. So not the averages, but the actual individual readings. And because they are individual observations, it allows us to compare the process data to the specs. This is a controlled process, so this is what we can see for the future. You see there are many observations above the upper spec limit, and the lower spec limit is 90. There are also many observations below the lower spec limit. So this is graphical evidence that the process cannot meet the requirements. A little further down, we get the X bar chart. Oh, by the way, I've copied and pasted all these charts into my report. So here's the X bar chart, and we need that because if the process is not in statistical control, none of this is valid information. But this process is, as you can see from the X bar chart. So we can expect the future of this process to look pretty much like it looked during our study. So as I say, I pasted all that information into the report. And looking at the report, we'll see the X bar chart shows statistical control, and the individual chart, which shows the individual data points. So my conclusion was the PPX and CPX indices are close to one another, and they will be if the process is in statistical control. All of the indices are unacceptable. They should all be at least 1.33, and they hover in the range of 0.5. This process is not capable of meeting the requirements. If you add up the expected number beyond the control or beyond the spec limits, you'll see they're around 13.2%. You can also confirm that by looking at the X bar .1 chart. There are 5 observed points below the lower spec and 8 observed points above the upper spec. And since the process is in control, this is roughly what we can expect in the future. This indicates a Lean Six Sigma project needs to be considered to explore ways to reduce the process variability, because we could see from the histograms the process variability is what's wrong with this process. It's just too great.